everyone. So let's talk about ratios and rates and what those look like. So remember that a rate or even a ratio is a comparison of two things. Okay, so compares two, and I'm going to say units instead of things. It kind of sounds fancier. Okay. So let's start with this first problem. It says the ratio of the number of boys to the number of girls in choir is 5 to 4. Okay, so we're comparing boys to girls. Okay, and then what it says is that it's 5 to 4. So that would be the ratio. Okay, now what it's wanting is it's giving us this extra information. There are 60 girls in the choir, so how many boys? Well, we've done stuff like this. We use our old scale factor new table, and we're going to start with what we know first, which is this 5 over 4. 5 over 4, and we're going to keep our units. So boys on top, girls on the bottom. And same thing over here on this side, boys on top, girls on the bottom. So we took care of this. This is taken care of right there. Now we're moving on to the second part of information that says there are 60 girls in the choir. So I'm going to plug that information in where it goes. Well, girls is on the bottom, so I'm going to put 60 right there. Now what I don't know and what the question is asking is how many boys. Okay, so at this point, you guys have a few different options. One thing that you could do is think about in your head is what I want to think about. This is my thought process over here is 4 times some number equals 60. Okay, and so I need to figure out what that number is. Well, if I'm thinking, well, what's the opposite of multiplication? If I don't know what I need to multiply by, I can work backwards, right? So if I work backwards, what operation is that? Division. Okay, and so then another way that I could write this is I could say 60 divided by 4. And that's going to give me whatever this special number is. Okay, and that special number is going to tell me how I jump from here to here. Now, this process that I just did, if we remember, if we want to kind of remember what that is our scale factor. Okay, so scale factor is when we stack new over old or new over original. So if I go back to my table right here, the new number was the 60 girls, and originally I had 4 girls. Okay, and so that's why that we divide right here is if we don't know what that number is. Sometimes we can look at that and we know what numbers should get there. Okay, and so in your calculator, or maybe you already know this, what we're going to do is we're going to do 60 divided by 4. And 60 divided by 4, let me do this color up here, is 15. Now what we're going to do with that 15, that's our scale factor. Our scale factor tells us how that we proportionately increase a ratio. Okay, because I still want to have that same ratio. And what I mean by that is whatever fraction that I have over here in the new column, when I simplify it, it's going to be the same number as the simplified ratio in the first column. So that's a nice way to check ourselves. And sometimes we forget that, or maybe some of us didn't know that we could do that. So watch what happens here, okay? So I'm going to do this math, which is 5 times 15, which is 75. Okay, and I'm going to erase that X right there. I'm going to rewrite this. So 75. So we answered this question, how many boys are in the choir? There's 75 boys. Okay. Now, if I wanted to check myself, okay, what I know is that the ratio of boys to girls is 5 to 4. And then my new scaled up ratio is 75 over 60. Now you have 2 different ways you could check this. We could come in here and we could simplify this, okay? Some of you may start at 5 and then we keep going. Okay, that's a great way to do that and see if we can end up back with 5 and 4. But another thing that you could do, okay, is we could, if I read this problem, if I read this fraction that I see right here, that fraction bar is division, right? So what I could do is 5 divided by 4, and 5 divided by 4 is 1.25. Now I'm going to do the same thing here. 75 is on top. My fraction bar means division. So now I'm going to do 75 divided by 60. Now, if I solve this correctly, and I'm thinking about this in a proportional way, then these should be the same, okay? Because all that I did was take the same fraction, the same rate, the same ratio, and I scaled it up. I made it bigger, but I didn't change the relationship between the two numbers. So if you guys pop this into the calculator, you're going to get $1, or I say $1.25. That's what it looks like, 1.25. Okay, and so what that tells me is that this 75 is the correct answer. Okay, that's just a nice quick way to check yourself. Okay, so let's do these other two problems. Okay, now that we kind of have an idea of what is happening. All right, so there are 39 calories and 12 fluid ounces of a tea drink. Based on this information, how many calories are in 36 fluid ounces of the tea? So when you are reading problems like this, the very first thing I want you to do is think of what two units are you comparing, or what two things are being talked about in the problem. And what I see is calories and ounces. And I just kind of abbreviate these so it makes it easier for me to set up my table. And so now I'm just going to jump in here and I'm going to set up my table. So old, scale factor, new. And I'm going to start building it with the information that's been provided to me, and that's going to really honestly tell me what it is that I'm missing and then what it is that I am solving for. Okay, so there's 39 calories. Let's do a different color. I like my colors. 39 for 12 fluid ounces. Okay, and based on this information, how many calories are there in 36 fluid ounces? Okay, well, all that it gave me is for 36 fluid ounces, which goes here. Okay, and so what I'm missing is this. That's what we want to find out, is what does X equal? Okay, so some of you might be able to tell me that 12 times this number equals 36. Do you know what 12 times what equals 36? Okay, well, if you don't know, I showed you a trick. Okay, we'll use our formula for scale factor, which is new over original. And so 36 over 12, and that's going to simplify to 3. Okay, so that means that my scale factor for this problem is 3. So I'm going to multiply old numbers times 3, and it's going to give me my new numbers. Okay, so I'm going to get out my handy dandy calculator because by golly, I don't want to make a mistake. 39 times 3 is 117. Okay, now I want to backtrack. The other thing that I want to do is whenever we get a number right there, I like to check it real quickly. I want to see, make sure I didn't make a mistake, because there's so many areas that we could make a mistake. And I want to double check that 12 times 3 equals 36. So click, clack, clack, clack. This is me typing in the stuff. Oops. 12 times 3 is 36. So that's correct. So I'm carrying through. There's my answer. So if I drink 36 fluid ounces, that's 117 calories. All right, let's do this last one. Okay, so a machine in an office can shred 65 sheets of paper every 5 seconds. How many sheets of paper can the machine shred in 60 seconds? It's almost a tongue twister, isn't it? Somebody say that really fast. Okay, so I'm going to do P for paper, and I'm going to do S for seconds. Okay. All right, so here we go. Make that table old, scale factor new. So information given was 65 sheets of paper for every 5 seconds. How many sheets of paper can be done in 60 seconds? Okay, Some of you may know 5 times what equals 60, but if you don't, ain't no thing. We're going to do new over original in case we don't know, and we will do 60 over 5. And does anybody know what that gets you? If you want to pause it and check on your calculator, or maybe you already know, it's 12. Okay. And so what that tells me is that this is going to be 12. That means I'm going to multiply everything by 12 to get my answer over here. So this looks like it's going to be a pretty big number, don't you think? All right, so I'm going to do 12 times 65, and 780 is my answer. Okay, so hopefully that helps.